Section 3.1, Graphing Linear Inequalities. To graph linear inequalities, we need to first determine what type of boundary line we will have. If we see a less than or equal to or greater than or equal to, we're going to have a solid boundary line that is included. If we have less than or greater than, we will have a dashed boundary line that is not included. So we're going to have a solid or a dashed boundary line. We're going to graph using slope-intercept form, y equals mx plus b. You may remember this from algebra prep. Remember, m is our slope, and b is the y-intercept. So we start here, and then we use our slope to find the next location. So let's graph the inequality. I have x minus 4y is greater than 4. So first of all, I need to get this into the y equals mx plus b form. So I have x minus 4y is greater than 4. So I need to subtract x. So negative 4y is greater than negative x plus 4. And I need to divide by 4 to get y by itself. Divide by negative 4. And remember, when we multiply or divide by a negative number, we need to switch our sign. So y is less than 1/4 x minus 1. So we have our slope, and we have our y-intercept. So I'm going to start at my y-intercept of negative 1. And from negative 1, we should do that over. That doesn't look very good. So we're going to start at negative 1. And to get to my next point, I'm going to go up 1 unit to the right 4 units. So up 1 to the right 4. Up 1 to the right 4. And we can continue this pattern forever. I can now create a straight line, hopefully, connecting these together. But I need to erase that line because we have a less than sign. So we need to use a dashed line to connect our points. And now to shade, we will shade where y is smaller than. So we want to shade below our line. Let's graph 3x plus 2y is less than or equal to 18. So I need to get this into y equals mx plus b form. So 3x plus 2y is less than or equal to 18. I'll subtract 3x. So 2y is less than or equal to negative 3x plus 18. I'll divide by 2. So y is less than or equal to negative 3/2 x plus 9. Note this time we didn't divide by negative numbers, so our sign stayed the same. So we want to start at positive 9. 1, 2, 3, 4, 5, 6, 7, 8, about here. And then to get to the next point, we'll drop 3 units and go over 2. Okay. And we have a less than or equal to sign, so our graph will be a solid line. And we want to shade less than, so we want to shade below our line. A system of inequalities is when we graph at least 2 inequalities on the same graph to determine an appropriate solution area. So let's graph the 2 systems. So note that we already have y is less than negative 3x plus 12. So we already have it solved for y. So we need to go up 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12-ish, about up here. So go down 3 to the right 1, about here. 1 over 1. Oops. So here we have a less than sign, so we need to dotted line. Hopefully yours looks a little nicer than mine. And we want to go less than, so I'm going to shade underneath here. Okay. X is less than 2y. I'm going to rearrange these so it's 2y greater than x, so just flip them over so that it's in the form that we're used to. Dividing by 2, we'll have y is greater than 1/2 x. So we don't have a y-intercept, which is okay. But we start at 0, and we go up 1 over 2, up 1 over 2, up 1 over 2. And this one will also have a dashed line. And this time we want to shade above this line. So notice there is some area that was overlapped. The part where it's kind of green here, this part here is the solution set, because this is where they both have their shading covered up. The region that is the heavily shaded area is called the region of feasibility, of feasible solutions, or the feasible region, since it is made up of all the points that satisfy both statements. So here is the feasible region, since both parts were shaded in this area. So let's graph the feasible region for the system. We have y is less than or equal to negative 2x plus 8. So it's already into y equals mx plus b form, so we just need to go up 8. So 1, 2, 3, 4, 5, 6, 7, 8. Oops. 8. And then go down 2 to the right 1. Down 2 to the right 1. Continue this pattern. It is a solid line. And we want to shade below, since it's less than. So we want to shade below. And then we have x in between 1 and negative 2. So x is less than 1 would give us this line here. So x is 1 gives us a vertical line, and it's solid at 1. And x is 2 is a vertical line at negative 2. So x has to be in between negative 2 and 1. So we can extend this all the way up here if we want. So if x is in between there, we're going to want to shade in between these two. So notice that our feasible region is in between here, as this is where they are both shaded. And note that this feasible region in this example is unbounded, since the region is not enclosed by boundary lines on all sides. So yes, there is boundary lines on the left, on the right, and up above. But down below here, it'll just keep continuing down. So it's unbounded down below. Let's graph the feasible region for the system. We have 2x minus 5y is less than or equal to 10. x plus 2y is less than or equal to 18. X is greater than 0 and y is greater than 0. I should say greater than or equal to 0. So let's first start off by getting 2x minus 5y less than or equal to 10 into our form. So 2x minus 5y is less than or equal to 10 is the same as negative 5y is less than or equal to negative 2x plus 10. And then divide by negative 5. So y, we divided by negative 5, so we need to flip our sign. Y is greater than or equal to positive 2/5 x minus 2. So we will start at negative 2, and we will go up 2 over 5. So 1, 2, 1, 2, 3, 4, 5. And we have a solid line here. And we want to shade above this line, since it's greater than. Greater than you shade above, less than we shade below, if you haven't caught on to that yet. Okay. Now let's do x plus 2y is less than or equal to 18. So x plus 2y is less than or equal to 18. 2y is less than or equal to negative x plus 18. Divide by 2. So y is less than or equal to negative 1/2 x plus 9. Note we don't flip the sign because we did not divide by a negative number. So we start at positive 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, about more like about here. And we're going to drop down 1 and go over 2. So 8, 2, and it would continue. Sorry, my lines are just awful. Again, we would have a straight line. And if we were to extend this, we would go right through here. Okay, and now we want to shade below this line. So we want to shade below this line. We can already see where they're overlapping. But we also have the indication that x has to be greater than or equal to 0. So x has to be greater than or equal to 0. So we also have to shade above here. And y has to be greater than or equal to 0. So we also have to shade over here. So notice where it's all black here. In this region, the middle region here, is the region in which they are enclosed. So this feasible region is bounded, since the region is enclosed, by boundary lines on all sides. Okay, so it's in the middle of all this stuff happening. Graph the feasible region for the system. So let's first start by getting y into the form of slope-intercept. So we have negative 3x plus 4y is greater than or equal to 10. So 4y is greater than or equal to 3x plus 10. Divide by 4. y is greater than or equal to 3/4 x plus 5/2. So 5/2 is 2.5. So when we go ahead, we'll go up 2.5, go down 3, 1, 2, and over 4. Okay. We have a solid line. And it looks like we want to shade above this line since it's greater than. So we will shade above the line. Okay, let's do x plus 3y is greater than 6 now. So we have x plus 3y is greater than or equal to 6. Subtract x, so 3y is greater than or equal to negative x plus 6. Divide by 3. Y is greater than or equal to negative 1/3 x plus 2. So this time we'll start at positive 2. And we'll go down 1 to the right 3. And again, we have another solid line. And we also want to shade above this line. Did anybody notice my mistake, out of curiosity? Looking at this one here, we should have gone up 3 over 4, not down 3 over 4. So let's erase our lines here and start over so that we get the correct line so we can see what happens. I apologize for making that mistake. Don't want to erase my work here. Okay, so we're going to start at 2.5. And we're going to go up 3, 1, 2, 3, over 4. And we're still going to have a solid line. And we still have to shade above the line. But now we get to shade it in the proper location. So now let's graph y is greater than or equal to. So we go up positive 2. We're going to go down 1 over 3. And here we're still going to have a solid line. And we want to shade above the line. But we have one more parameter. Y has to be less than or equal to 1. So if y is less than or equal to 1, we're going to go to our y equals line. And it has to be less than this number. So we're going to shade down here. Is there any location where they are all shaded together? No, they never overlap. Well, they never all overlap, I should say. So there is no solution, since there is no feasible region. Okay. Carmilla and Walt produced handmade shawls and afghans. They spin the yarn, dye it, and then weave it. A shawl requires 1 hour of spinning, 1 hour of dyeing, and 1 hour of weaving. An afghan needs 2 hours of spinning, 1 hour of dyeing, and 4 hours of weaving. Together they spend at most 8 hours spinning, 6 hours dyeing, and 14 hours weaving. So I'm going to let shawls represent X and afghans represent Y. And we're going to complete the following table here. All right. So it takes 4 It takes shawls 1 hour of spinning, it takes 1 hour of dyeing, and 1 hour of weaving. Afghans take 2 hours of spinning, 1 hour of dyeing, and 4 hours of weaving. We want to spend at most, so we want to spend less than or equal to 8 hours of spinning, less than or equal to 6 hours of dyeing, and less than or equal to 14 hours of weaving. So let's set up a system. We have x plus 2y is less than or equal to 8. So let's simplify this one. So 2y is less than or equal to negative x plus 8. Y is less than or equal to negative 1/2 x plus 4. So here's one that we need to graph. We also need to graph x plus y is less than or equal to 6. So y is less than or equal to negative x plus 6. So here is our second one. And our third one is x plus 4y is less than or equal to 14. So 4y is less than or equal to negative x plus 14. Divide by 4. Y is less than or equal to negative 1/4 x plus 7/2. So then our third that we need to graph and to consider. So let's graph them. So I want to go up 4. So I'm going to go up 4. And then I'm going to go down 1 over 2. And we have a solid line. Instead of making a mess of the shading, just keep in mind that we have to shade below that line. I also want to graph y is less than or equal to negative x plus 6. So we'll go up 6 and then down 1 over 1. So it slightly overlaps. We're going to have a solid line here as well. And again, we want to shade below this line. So right now, our shading is below both of those lines, especially where they intersect. And then finally, we have y is less than or equal to negative 1/4 x plus 7/2. Well, 7/2 is the same as 3.5. So we'll go up to 3.5. That was a bad up to 3.5. And we're going to go down 1 to the right 4. So down 1 to the right 4. So pretty, not very, so it's going to go like this. And it's also going to be below, So our shading, since it's below every single one of them, where they would overlap is this area here. Now granted, we really don't care about the negative area because it doesn't make sense. We can't spend negative 2 hours of spinning or dyeing, etc. But we want to answer a couple of questions. On the next page it asks us, so using our graph, can we do 3 shawls and 2 Afghans? So if we do 3 shawls and 2 Afghans, that our x is 3 and our y is 2. So let's see if 3, 2 is in the region. So is 3, 2 in our region? So can we go over 3 and up 2? It sure is shaded, so yes, we can. So we can say yes. How about can we do 4 shawls and 3 Afghans? So is 4, 3 in our feasible region? So can we go over 4 and up 3? Is this in our region that's shaded? No, this is not. So no, we are not able to do 4 shawls and 3 Afghans because it's not in the shaded region. And this concludes section 3.1 on graphing linear inequalities.